Okay, the last thing I'm going to talk to you about is changing mixed numbers into improper fractions and improper fractions into mixed numbers. So let's start by changing an improper fraction into a mixed number. So for instance, if we have 21 over 8, remember the denominator tells us how many pieces are in our whole, which means that if I have a piece here, I know that I have 8 pieces. So let's see. Okay, so I have 8 pieces here, and our numerator tells us how many are shaded in. Well, it's definitely more than 8, but let's just begin there. So we know we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. But we have 21 pieces, so I'm actually going to have to draw another picture. Okay, and we know that this has to have 8 pieces because there are 8 pieces in our whole. So 1, 2, 3, 4, 5, 6, 7, 8. And I need to have a total of 21, and I've only got 8 so far, so let's keep counting. 9, 10, 11, 12, 13, 14, 15, 16. All right, I don't have enough yet, so let's draw another one. One, 2, 3, 4, 5, 6, 7, 8. Okay, we left off at 16, so let's keep counting. 17, 18, 19, 20, 21. I have 21 eighths. Now, this is written as an improper fraction, and we're going to write it as a mixed number, meaning we are going to count the whole pieces first. So I have 1, 2, so I have 2 whole pieces. And how many do I have left over? I've got 1, 2, 3, 4, 5. I have 5 eighths left over, and that is my mixed number. Now, if you want to know how to do this using a quick procedure, the way that we do it is we divide the numerator by our denominator. So our divisor is 21, and our dividend is 21, and our divisor is 8. So 8, let's see, 21 can be divided by 8 2 times, and 2 times 8 is 16, and 21 minus 16 is 5, or when we borrowed, 11 minus 6 is 5. So I have a remainder of 5, and what I do is I write my remainder as my numerator, and my divisor remains my denominator. So you see we get the exact same answer. Okay, so now you know how to change an improper fraction into a mixed number, but what if we have a mixed number and we want to change it into an improper fraction? And we will need to do this when we start using operations with fractions. So this means that I have one whole piece and part of another piece. And we know our denominator is 12, which means that we've got 12 pieces total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's 12. So I have 12 pieces here, and of those pieces I have 7 shaded. So there's 1, 2, 3, 4, 5, 6, 7. But remember, as an improper fraction, we're not going to count this as a whole. We need to turn it into fractional pieces. So our denominator is 12, so I'm going to I'm going to cut it into 12 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And of those 12, 12 of them are shaded because I have one whole piece. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now if I want to write this as an improper fraction, I know that the size of my pieces are in twelfths. And now let me count how many I have. I have 1, 2, 3, 4. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 over 12. However, let me show you how to do this using a procedure. So if I write this 1 and 7/12, I'm just going to write it rather large. And I call this the Texas method because we actually can put our T and our X. And we are going to go around from the bottom to the top. So we do 12 times 1 plus 7. So 12 times 1 is 12 plus 7 is 19, just like we saw before. And our denominator stays the same, so we have 19 over 12. And that's what we'll be looking at tomorrow.